Hello everyone. Today let us discuss about MCQ questions in real numbers chapter 1 class 10th. Now here we have first question, the prime factorization of natural number. We have to find out. The number is given 288. So first question is 288 prime factorization we have to find. So 288 is divided by 2, 144. Again 144 can be divided by 2, that is 72. Again 236, 72, then 2 18 times 36, then 2 9 times, then 3 3 times. So we have 288 is equal to 1 2 3 4 5, 2 power 5 into 3 power 2. So you can see that is option A. So question number 1 is option A. Question number 1, option A. Next, second question. It is given HCF of 364 comma 360 comma 764. Given that HCF of 360 comma 64 as 8, we have to find out LCM. We have a concept called as HCF into LCM is equal to product of two numbers. Product of two numbers. So what we can write, HCF is 8, 8 into LCM of 360 comma 64 is equal to, two numbers are 360 and 64, so you can write it as 360 into 64. So LCM of 360 comma 64 is 360 into 64 divided by 8. Now this is 8 ones are 8 eights are 64. Now after multiplication, 0 8 6 are 48. So it is 24 plus 4 28. So the answer is 2880. So LCM of 360 comma 64 is 2880. 2880 is option A again. So this question is also option A. So first and second questions are over. Now let's do the third question. Question number 3. Question number 3, what it is given? Two numbers are given. A is equal to xy to the power of 3 and b is equal to x to the power of 4 into y to the power of 2 into z to the power of 1. We want HCF of a comma b. So HCF of a comma b is, so HCF of a comma b, whenever we find HCF we write only common factors. So here common factors are x, y, here also only x and y. So x and y are the common factors. So x into y, and then we take their lowest powers. The lowest power of x is 1 here. So we should write x to the power of 1, and the lowest power of y is 2 here. So y to the power of 2. So what is the answer? X into y to the power of 2 is the HCF of two numbers. So here you remember HCF, whenever we find, we take only common factors and their lowest powers. Here lowest power is 1, here lowest power is 2. So x into y to the power of 2, option D. Now question number 4. Here it is given LCM of two numbers is 1200. Which of the following cannot be the HCF? Here we have to remember one point. HCF of two numbers. HCF of any two numbers is always a factor of LCM of same two numbers. Factor of LCM of same two numbers. So you have to check whether which of the following is not the LCM. We have to check. Which number cannot be the factor of 1200 there? B, 500. So option B is correct because 500 is not a factor of 1200. So that cannot be the HCF of two numbers. Next question, question number 5. The HCF of 26 and 169. Here also the concept is same. That is HCF into LCM is equal to product of two numbers. This concept we have to remember. Product of two numbers. So according to this, here HCF is given 13, HCF of 26 comma 169 it is given 13, and we have to find out LCM. So substitute here, that is 13 into LCM is equal to 26 into 169. So LCM is equal to 26 into 169 by 13. So after cancellation, 13 ones are 13 twos are. So what it is, 2 into 169. So LCM of 26 and 169 is 8, 12, 1, 3. So 338. LCM of 26 and 169 is 338. The option is C. Option C is correct. Now let's go to the next question. Question number 6. What is question number 6 here? There are two numbers, 616. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So we have to find maximum number of columns. Whenever they ask you maximum number, greatest number, highest number, which is common in both and which can divide both the numbers, we have to understand, we have to find HCF there. So given numbers are 616 and 32. We have to find HCF of 616 and 32. So we can clearly, by seeing the option HCF, we have to find HCF is a number which divides both. We can see clearly options are 5. This is option A. Option A is 5. Option B is 6. Option C is Option C is 7. Option D is 8. Here we can see clearly only 8 can divide both 32 and 616, or we can find out HCF directly, like by using that prime factorization method we can find out HCF, or 308 again 2154 two sevens again two sevens. Here now not 7, now 7 11s. Here 2 16 2 8 2, 4, 2, 2. So 616 is equal to 2 power 3 into 7 power 1 into 11 power 1, and 32 is equal to 2 power 5. Now HCF we have to find. Because it is objective, directly you can select which number divides both, that is 8 actually. But if you want to find out this method, factorization method, then HCF of 616 comma 32, we have to select the common factor first. There is only one common factor, that is 2. So 2 power, lowest power we have to take 2, lowest power of 2 we have to take, that is 3. So what it is, 2 power 3, 2 power 3 is 8. So the answer is 8. Option D is correct here. Option D. Question number 6 is done. Now question number 7, we have to find HCF and LCM both. So that order is also important. First they asked HCF and then asked LCM. So let us take the numbers 12, 12, 21, 12, 21 and 15. We know 12 is equal to 2 power 2 into 3 power 1, 4 into 3, and 21 is equal to 3 power 1 into 7 power 1, and 15 is equal to 3 power 1 into 5 power 1. So we want HCF first. HCF of 12, 21, 15 is equal to HCF. Whenever we find only common factor we take. Common factor is 3. So 3 power 1. 3 higher, 3 lowest power is 1 only. So 3 power 1. And no other common factor is there. So only 3 power 1. 3 power 1 is equal to what? 3. HCF is 3. Now LCM we have to find. Whenever we find out LCM, we take all the different prime factors. In prime factorization we have 2, 3, 5, 7. All these are there. And now highest powers of these factors we have to take. Highest power of 2 is 2, highest power of 3 is 1, highest power of 5 is also 1, highest power of 7 is also 1. So that is 4 into 3, 12, 12 into 5, 60, 60 into 7, 420. So the options are 3 comma 420. 3 comma 420. So option is what? A. Option A is correct. This is question number 7. Now let's see question number 8 now. In question number 8, they are asking to find the ratio between LCM and HCF of least composite number and the least prime number. Least composite number we know that is 4. Only 4 is divisible by more than 2 numbers, that is 1, 2, 4, and that is the least number. So least composite number is 4, and the least prime number we know 2 because 1 is neither prime nor composite. So the numbers are 4 and 2. Now LCM of 4 comma 2 is 4, and HCF of 4 comma 2 is 2. Now the ratio of LCM and HCF is what? 4 is to 2, that is 2 is to 1. So which option is correct? 2 is to 1. Option C is correct. Question number 8, option C. Now question number 9. In question number 9, it is about again LCM into HCF is equal to product of two numbers. It is given LCM of x comma 18 is equal to 36, and HCF of x comma 36 x comma 18 is equal to 2 is equal to 2. We have to find out the value of x here. So we know already LCM into HCF is equal to product of two numbers, that is x into 18. Here we know LCM is 36 and HCF is 2 is equal to x into 18. We want x here. X is equal to 36 into 2 by 18. So we know 18 ones, 18 twos are 36. So x is equal to 2 into 2. So x is equal to 4. Option C is correct. Option C is correct. Now question number 10. It is about a number which is ending with the digit 0. So whenever we want a number ending with the digit 0, that number should have the prime factors 2 and 5. If there are 2 and 5 both in the prime factorization, then the number will be ending with 0. So if a number is having, and the number it is given here in this format, a into 5 to the power of n. So in this a into 5 to the power of n, if a is any prime number, we cannot say that a is only 2 there, okay? Many number of prime numbers are there which are not 2. So first option is not correct. When you opt prime number, there are different prime numbers, not only 2, so that is not correct. But when you select an even number, in every even number is there in the form 2 into some value. This n can be any number, but before that what it is, 2 will be there. It is compulsory, it will be multiple of 2. So what if a is an even number, in that compulsory 2 will be there. So when there is 2 in a, there will be 2 and 5 in the prime factorization. So it can end with the digit 0 for some natural number n. So what should be a? Here a is an even number. If a is an even number, it can end with the digit 0. So option B is correct. Option B is correct. Next, question number 11. Let us see question number 11. In question number 11, what it is given? It is about there are 312, 260 and 156 students are there in 10th, 11th and 12th respectively. Buses are to be hired to take these students to a picnic. Find the maximum number of students who can sit in each bus if each bus takes equal number of students. Then again maximum number of students from 312, 260 and 156. So already, as I already mentioned, whenever you want maximum number of students or greatest number and that divides the given number, so what we need to find out HCF. So let us find out the factorization of these. 2 table, 2 ones are, 2 fives are, 2 six are. Again 2 table, 2 sevens are, 2 eights are. Again 2 table, 2 39s. Again 2 table, 2, oh not 2 table, now 3 table. 3 table 39s. So 312 is equal to 2 power 3 into 3 power 1 into 13 power 1. Then 260. 2 ones are, 2 threes are 0. Again 2 fives are 10. 2 six are, no, not correct. 1 minute. 2 six are 12. 2 fives are 30. 2 fives are 10. Again we can take now 5 table, 5 13s are. So what 260 is equal to 2 power 2 into 5 power 1 into 13 power 1. Then 156. 2 table, 2 sevens are 14, 2 eights are, again 2 39s are, again 3 13s are. So what is 156? 156 is equal to 2 power 2 into 3 power 1 into 13 power 1. So in all these we want HCF. So when we want HCF, what we have to do? You have to take the common factors and their lowest powers. HCF of 312, 260, 156 is equal to, what are the common factors we have everywhere? 2 is there everywhere and 3 is here and the last one, but 3 is not there in the middle one. So 3 is not a common factor, but 13 is there in all the 3. 13 is there. So what? 2 into 13 are the common factors. Now we have to select the lowest powers. The lowest power of 2 is 2 and the lowest power of 13 is 1. Everywhere 1 is only there. So 2 power 2 into 13 power 1, which is 4 into 13. 4 into 13 is 52. Answer is 52. So option B is correct. Question number 11. Option B is correct. Now question number 12. Numbers are given 4, 7 and 14. You have to find out all the three rang at 7 a.m. When will they ring together again? So they will be ringing at their multiples. First one will be ringing at 4, 8, 12, 16, 20. So multiples of 4 are coming. And the second one, 7 multiples. They ring at 7, 14, 28 like that. And the third one, multiples of 14, 14, 28, like then 56 like that, at multiples of 40 to 56 like that, at multiples of 14 third one will ring. So all the three when they ring again at least common multiple. So whenever this type of question comes, you need to remember you have to find least common multiple. So how do we find least common multiple? 4 is nothing but 2 power 2, 7 is 7 power 1, 14 is 2 power 1 into 7 power 1. So LCM of 4, 7, 14 is, you have to write all the factors 2 and 7. All factors are just 2 and 7. And the highest power of 2 is 2. Highest power of 7 is 1. So it is 4 into 7, that is 28. That means what? After 28 minutes they ring again. But already they rang at 7 a.m. So next time, second immediately after 7 a.m. when they ring, at 7:28 a.m. they ring. So which option is correct? Option A is correct. At 7:28 a.m. again they ring. So this is about question number 12. Now next let's see next question. 13th question. This is about product of a rational and irrational. We have to remember product of a rational and irrational number is always irrational. Okay, not only product, sum. When you have one rational and one irrational, then sum or difference or product or quotient all will be irrational again. The results will be irrational again. So here option is what? Always irrational. So option B is correct. When both are means what? In which the given two numbers in which one is rational and other is irrational, the result is again irrational. We have to remember. Now the question number 14. What is the smallest irrational number by which root 18 should be multiplied? So to get a rational number, we can write root 18 as root 9 into 2. That can be written as again 3 root 2. So by this we should understand 3 root 2 should be multiplied by root 2 again. So that will become rational. So root 18 should be multiplied by root 2. Option C is correct. Option C is correct. It should be multiplied by root 2. Right. Question number 14 is done. Now question number 15. Question number 15. If two positive integers a and b are written as a is equal to p power 3 into q power 2 and b is equal to p into q power 3, where p comma q are prime numbers, then we want HCF of a comma b. HCF of a comma b is again common factors. We have to select p and q, both are common factors and their lowest powers. So p lowest power is 1 here, p power 1 it is, p means what? P power 1. Here lowest power of p is 1. So here it should be p power 1 into q power, q lowest power is 2. So q power 2. So that is just p into q square. P q square is which option there? Option A. Option A is correct. Question number 15. Now question number 16. On one morning walk, three persons step off together and their steps measures 40, 42, 45 respectively. What is the minimum distance each should walk so that each can cover the same distance in complete steps? So here what again? Steps will be completed in multiples of 40, multiples of 42, multiples of 45. So common multiples, and we want minimum distance. We need to find out least common multiple. In this type of questions, we have to find least common multiple. So least common multiple of what we have to find? 40, 42 and 45. We know 40 can be written as 8 into 5. 8 is 2 power 3, so 2 power 3 into 5 power 1. 42 can be written as 6 into 7, that is 2 power 1 into 3 power 1 into 7 power 1. 45 can be written as 5 into 9 or 9 into 5, that is 3 power 2 into 5 power 1. Now when we find out LCM of 40, 42, 45 is equal to, we can write it as all the prime numbers we have to list out first, that is 2 into 3 into 5 into 7, and their highest powers. 2 highest power is 3, 3 highest power is 2, 5 highest power is 1, 7 highest power is 1. So that is 8 nines are 72. 8 into 9 into 5 into 7. This is 72 into 5, 360. 360 into 7, 360 into 7, 0, 42, 2520. So the answer is 2520. At 2520 centimeters, all the three cover the same distance. So option D is correct. Option D is correct. Question number 16. Option D is correct. Next, question number 17. In question number 17, they have given three farmers have 490 kg, 588 kg, 882 kg of wheat respectively. Find the maximum capacity of a bag so that wheat can be packed in exact number of bags. So again you have to find out maximum number that divides all the three. So you have to find out highest common factor, and the numbers are given 490, 588, 882. So factorization again, 490, 2 table, 2 2s are 4, 2 4s are 8, 2 5s are again. You can take 5 table, 5 4s are 20, 5 9s are 45. Now 7 table, 7 7s are 49. Next 588, 588 by 2 table, 2 2s are 4, 2 9s are 18, 2 4s are 8. Again 2 table, 2 1s are 2, 2 4s are 8, 2 7s are. Again, now 7 table we can take 7 twos are 7 ones are. Now 7 table again, 7 ones are 7 threes are. 882. 2 table, 2 fours are 2 fours are 2 ones are. Now 3 table we can take 3 ones are 3 fours are 12, 3 sevens are. Again 3 table we can take 3 fours are 3 nines are. 7 table, 7 ones are 7, 7 sevens are. Now 490 is what? 490 can be written as 2 power 1 into 5 power 1 into 7 power 2. 588 is what? 2 power 2 into 3 power 1 into 7 power 2. Like 882 is what? 2 power 1 into 3 power 2 into 7 power 2. We want HCF of these three. HCF of 490, 588, 882. What we have to select? only common factors we have to select in all the three. We have 2 in all the three, 3 is not there in all the three, and 5 is not there in all the three, but 7 is there in all the three. So what, 2 and 5 are common fact, 2 and 7 are common factors, and their lowest powers, lowest power of 2 is 1 and lowest power of 7 is 2. So it is what, 2 into 49, which is 98 kg. 98 kg. Which option? Option A. Option A is correct. Question number 17. Now question number 18. Yeah, this type of questions we have already in the textbook. It can be expressed as a product of prime numbers. Product of prime numbers. Every product of prime number, when a number is expressed as product of prime number, from uniqueness of fundamental theorem of arithmetic, we can say that it is a composite number. Number is given 6 into 5 into 4 into 3 into 2 into 1 plus 5. Now this thing is one number and only here 5 is one number. In these two we have 5 common. We can write it as 6 into 4 into 3 into 2 into 1 plus 5 is 1. So that is 5 into 20, 6 4 is 24 into 3 72 into 2 140, 144 plus 1 145. 6 4 is 24 into 3 72 into 2 144 plus 1 145. It is 5 into 145. 145 can be written as 5 table, 5 twos are 5 nines are. So we can write it as 5 into 5 into 29. That can be written as 5 to the power of 2 into 29 to the power of 9. Now given number is expressed as fundamental. Given number is expressed as product of prime factors. Since the given number is expressed as product of its primes, from uniqueness of fundamental theorem, it can said to be a composite number. So option B is correct. It is a composite number. That is correct. Now question number 19. Question number 19. LCM of two numbers is 60 times of their HCF, and sum of HCF and LCM is 366, and one of the number is 72. Then find the other number. So LCM of two numbers is given 60. 60 times the HCF. Let us take let us take the two numbers be A comma B and their LCM and HCF be X comma Y. So here what we know, LCM of two numbers is 60 times of their HCF. So we can write X is equal to 60Y, because LCM is 60 times of HCF. So you can take X is equal to 60 into Y. That is one relation. One more, sum of HCF and LCM is 366. One more relation, X plus Y is equal to 366. This is also given, and one of the number is given in A and B. Let A is equal to, one of the number is given 72. We have to find B. So by using this, first let us find out what is X and Y. By using this, what we can write in the place of X, we can write 60Y. So 60Y plus Y is equal to 366. So 61Y is equal to 366. So Y is equal to 366 by 61. Now this is exactly 6 times. So Y is equal to 6. 61 6 are 366. If Y is equal to 6, then X is equal to, X plus 6 is equal to 366. Then X is equal to 366 minus 6. So X is equal to 360. And Y is equal to 6. Here A is equal to 72. Now one more formula we have, LCM into HCF is equal to product of two numbers. So now we can write X into Y is equal to A into B. Here X and Y are LCM and HCF, and A and B are two numbers. Now let us substitute these values. 360 into 6 is equal to 72 into B. Now B is equal to 360 into 6 by 72. 6 ones are 6 twelves are 72 and 12 ones are 12 3s are 36. So 0. So B is equal to 30. So B is equal to 30 is correct option. So answer is option C. Option C is correct. You sometimes you may have this type of questions. You may confuse, so you should follow like this. For the next one, question number 20. Also, directly numbers are not given. Ratio of the two numbers is given. 15 is to 11. The two numbers are in the ratio. So here, what? Let us take the two numbers B, A and B. So A is to B is given as 15 is to 11, and one more HCF is given 13, and LCM is also given 215. So we can take A is equal to some 15x and B is equal to 11x. We know LCM into HCF is equal to product of two numbers A into B. So here LCM is 2145 into HCF is 13 is equal to 15x into 11x. So we get 2145 into 13 by 15 into 11 is equal to x square. X into x square. 15 and 11 we transpose this side. Now we can cancel 2145 and 11. 11 ones are 11 ones are 11. More 10 will be there. 104. So 11 nines are 99. More 55 will be there. 11 5s are 55. Now again we can divide by 15 table. 15 ones are 15. 15 ones are 15. 15 ones are 15. 4 5 45. So 15 threes are 45. So we got x square is equal to 13 square. So x is equal to 13. So x is equal to 13. Option, find the number. So they are asking number. So find the two numbers. That is 15 into 13 and B is equal to 11 into 13. 15 into 13, how much it is? 65, 6, 195. 195. A is 195 and B is 13, 13, 13. 143. 195 and 143. Option C is correct. Option C is correct. The LCM of two numbers is 9. This is one more. Question number 21. How it is given? The LCM of two numbers is 9. LCM is given 9 and their HCF 9 times the HCF. Okay, not 9 exactly. So like before only, one problem we have done already like this. So let us take LCM and HCF be x and y like before. So according to the given information, LCM is 9 times the HCF. So x is equal to 9y. One equation. The sum of LCM and HCF is 500. So x plus y is equal to 500. This is equation 2. From this x and y we can find out. Find their HCF. They are asking to find their HCF. So here what we can do, first let us find out this. 9y plus y is equal to 500. So 10y is equal to 500. So y is equal to 500 by 10, that is 50. So y is equal to 50. If y is equal to 50, substitute this. X plus 50 is equal to 500. Then x is equal to 500 minus 50. X is equal to 450. So they are asking here to find out HCF. HCF is what? 50. We already got here. Here HCF is 50. Y is HCF here. HCF is 50. So option A is correct. Option A is correct. Question number 21. Now question number 22 onwards we have assertion and reasoning. So you need to know, you have to find out the result and then write, select the option, correct option. So here first one we have HCF of two numbers is 16. HCF is given 16 and their product is given directly. Product of two numbers is given 3072. We have to find LCM. We know LCM into HCF is equal to product of two numbers. So what, LCM into 16 is equal to 3072 it is given. So LCM into 16 is equal to 3072. So LCM is equal to 3072 by 16. So we have to cancel now. 4 table let us use. 4 ones are 4 fours are 16. 4 sevens are 28. 2 7 27. So 4 6 are 24. 4 eights are 32. Again 4 table. 4 ones are 4 ones are 4. 4 nines are 36. 4 twos are 8. So we got LCM is equal to 192. What did they give? 162. So not correct. So what, assertion is false, reason is true. So option B. Question number 21, 22. Option D is correct. Next, question number 23. It is given that 2 is an example of a rational number. Yes, true, 2 is a rational number. The square root of all positive integers are irrational numbers. This is false because square root of all positive integers are not irrational numbers. Square root of 4 is what? 2. So, reason is false. Assertion is true, reason is false. So, this is option C. Assertion true, reason is false. Question number 23. Now question number 24. In question number 24, what it is given? The HCF of two numbers is 5 and their product is 150. So again same, HCF is given 5, product is given 150. We have to find LCM. LCM is equal to what? Product by HCF. Because HCF into LCM is equal to product of two numbers. So that is 150 by 5, 30. So what it is given? 30 it is given. So assertion is true, but reason is false because it is given HCF of PQ plus LCM of plus it is given. So that is wrong. Actually it is HCF of PQ into LCM of PQ is equal to P into Q. So reason is false. Assertion is true, reason is false. So question number 24 is option D. Now question number 25. In question number 25, they said 18 and 25 is a pair of co-prime numbers. Yeah, 18 and 25. If you observe, there is no number that divides these two numbers. 18 and 25 do not have any common factor other than 1. So what? They are co-prime numbers. So assertion is true. 18 and 25 are co-prime numbers. Assertion is true. Pair of co-prime numbers has a common factor 2. Reason is false because when they are co-prime numbers, they will be having Common factor 1. Co-prime factors have only one common factor, that is 1, but they said 2. So here assertion is true but reason is false. Option C is correct. Then question number 26. In question number 26, root x is an irrational number where x is a prime number. True. All the numbers which are there in the form root x where x is prime are irrational numbers. Are irrational. True. This is true. Square root of any prime number is an irrational number. That is also true. Assertion is true, reason is true, and the reason is correct explanation of assertion here. Same thing it is given. Square root of any prime number is an irrational number. Correct. That is also true. And it is a correct reason. So you can write that option as A. Now question number 27. It is given 3 into 5 into 7. 3 into 5 into 7 plus 7. Yeah, 7 common. It will be 15 plus 1. So 7 into 16. 7 into 2 power 4. It is expressed as product of its prime factors. So it is a composite number. A composite number has factors 1 and itself and any other natural number. True. So both are correct. And we can say reason is correct explanation of assertion because it is having more than two factors. So here also it is A, option A. Question number 27. Now question number 28. Assertion is 2 minus root 5 is an irrational number. 2 minus root 5 is an irrational number. True, that is an irrational number. Assertion is true because it is an irrational number. And the reason is what? The sum or difference of rational and irrational number is always irrational. True. So assertion is true, reason is true, and reason is the correct explanation of assertion. So option A is correct. This already we discussed. One problem came before. I already told you. Sum difference product quotient of one rational and one irrational is always irrational. That is true. Next question number 29. 12 power n ends with the digit 0 where n is a natural number. False, because 12 power n is 2 power 2n 2 power 2n into 3 power 1n. Since there are no prime factors, since there is no prime factor 5 in this factorization, it cannot end with the digit 0 for any natural number n. So that is false. Assertion is false, reason is true. Option D. Question number 29. Now question number 30. Question number 30. The HCF of 11 and 17 is 1. True, because they are prime numbers. They do not have any other common factor 11 and 17. So HCF is what? 1 only. Because they do not have any other common factor. If P comma Q are prime numbers, then HCF of P comma Q is always 1. True. Assertion is true, reason is true, and reason is the correct explanation of assertion. So these are the questions important, some important questions covered from main important topics in the chapter 1 real numbers. Hopes it will help a lot in your final exam and what all exams you are going to write. You will understand how to analyze the question, how to find the answers quickly for MCQs. Hope it will helpful to you. We'll make videos on other chapters also. Keep watching videos and write your exams well. Thank you.